Hello everyone, this is Sai Teja Karlapudi. This is the first part of my final exam of data analytics, and the first part is regarding the eBay auctions. We have to build a classification model to decide whether the auction of eBay will be competitive or not. For that, we have used a decision tree model. So initially, we have imported all the required libraries, and then we have loaded the data set into the data frame, and then we have seen the characteristics of the data over here, and we have seen the data distribution across each feature, and then we have used we also checked the null values, whether the data is null values or not, and then we have checked whether the data is complete or not. And here we have used clean names for cleaning the column names, and here we have changed the duration feature into a categorical variable, and here we have splitted the data into training and testing, where we have used 75% for training and the rest is for testing. Here it is the modeling part of the part 1, where we have used decision tree, and here in the pictorial representation you can clearly see the classification model of using decision tree. So next, after that, we have used testing model. We have used predict method for testing the model. We have tested both training and testing over here, and then we have used confusion matrix for evaluating the predictions of both training and testing. So we have received an accuracy of 85.87% for the training model, and for the testing we have received 82.35%. And we have also got the lift charts over here, and we have plotted the lift chart here, and this is the competitive decile wise lift chart. We have used a bar plot for plotting it. So for the n, from the metrics derived from the confusion matrix, we can clearly say that the model has done quite good with classifying whether the auction is competitive or not. We have achieved a training accuracy of 85.87% with a confidence interval of 95%, whereas we have got the test accuracy of 82.35% with a confidence interval of 95%. Now let's move to the second part of the project. Here we are using linear regression and neural networks. So initially we have loaded all the required libraries, and here we are loading the data set into the data frame, and here we are using glimpse to see the characteristics of the data, like data types and data type, number of rows and columns. And here we are seeing summary for seeing the data distribution across each feature. We are checking here for the null values and whether the missing values in the data, and here we are cleaning the data columns to make sure there are no unnecessary characters between the column names. So here we are using select for pulling out the required feature for the analysis on the data set, and here we are grouping each and every feature like it's a versus diagram, so which shows the correlation between each and every feature. So this is all the statistics for those things, and this is the plot for the above data. Like we are seeing the frequency versus spending diagram, how spending will react to the frequency increase or decreasing, like that kind of things. And this is similar kind of plot, but this is for the last updated days and spending. And here we have splitted the data into training and test for the linear regression, where 75% is for training and rest is for testing. And this is the statistics for the model, and here we are predicting the accuracy of the model. We are using mean error and mean square error and other kind of metrics, and these are the maximum and minimum values which we pulled for the neural networks model. And here we are scaling the data for the neural networks, and here we are seeing the structure of the data for the neural networks, and we are checking null values over here. And here we are splitting the data for the neural network model, for which is 75% for training and 25% for testing. And this is the neural network model that we have built, and this is a summary, and this is the prediction of the model. Here we are testing the performance of the train and test data sets, and this is the actual versus predicted plot. And at the end, we finally found that after evaluating the performance of the neural network model, the RMSE and R2 values for the neural network are found to be 164.47 and 0.38 respectively, But whereas for the linear regression model, they are as 128.14 and 0.52 respectively. As we already know that the higher R2 value and the lower RMSE value indicate that the regression model will perfectly fit the model. So with respect to this problem, linear regression model is doing better.